All right. I'll be talking about REST 101, the basics of building and using REST APIs. First, a little bit about me. Becca, thank you for the introduction. So I'll just do a little bit of recap. I come from a traditional CS degree background. I graduated from McGill University in Montreal with a CS degree before going straight into industry. I've worked at a variety of companies, primarily retail, Microsoft being the odd one out there. And I currently am a senior software engineer at Amazon. As Becca mentioned, I do have 10 years of experience. So I've seen things. I work from home full time, and I have 2 work from home coworkers. The first is Europa, and she really likes excessively large IntelliJ projects because they keep her cat bed warm. And I have Callisto, who is just a all-around good pal to have for debugging, emotional support. She's just there to live her best life. All right, I will be talking about REST APIs, and I'm going to first go through some theory topics and then go into how these theory topics are applied. I'm not going to go into the nitty-gritty details and intricacies of REST. I'm going to focus on what's practical and what you want to keep in mind when you are building REST APIs for yourself. And when would you be building REST APIs? There's a few different scenarios. One is you are a full stack developer and you're building backend REST APIs for your website. If you are the same person building and using the REST APIs, if you make a few mistakes in the design, no big deal, you'll just make the change on both sides. If you are building a REST API for a different team, a front-end team or a mobile team, it's a little bit harder. They might get a little bit annoyed with you if you keep changing the APIs, but with some discussion, you can still work it out. The highest stakes situation is when you are selling your API to external customers and your company makes money off of the API. You have to be very careful when you design APIs for external customers because you're not going to be able to change them. Once customers start using it, they don't want to change. And if you force them to change, they might stop using your product. An example of a product like this is the Stripe API, where people can create and execute transactions for their online stores only using an API. Of course, once someone builds a website, they don't want to have to keep updating it because you launched a new version or you forgot to update your URLs or you wanted to change your HTTP methods. So it's really important when you have external customers to build high quality APIs. And it's always great to have high quality, even if you're the one who's using your API. For curiosity, for anyone who's curious, if we want to fully expand all these acronyms, we get representational state transfer application programming interfaces, which of course nobody actually says. Most of the time I forget what REST means. People will say REST or RESTful web APIs. I think most of us will say API instead of application programming interface. All right, getting into the theory. The most important thing, one of the 2 most important things in my opinion about building RESTful APIs is that all resources are uniquely identified and retrievable with the URI. Sometimes we say URI, but most of the time we'll say URL. Some libraries will use URI in their interfaces. So just to clarify, if you see URI and URL in RESTful web APIs, they are the same thing. When I say resource here, it means the entity, the object, the thing that you are retrieving. They are referred to as resources generally when we talk about REST APIs. An example of this, I have 2 cats at home and I would like to uniquely identify one of my cats, Callisto, and I can create a URL that has Callisto's name that uniquely identifies her. We'll go more into unique identifiers, but because I only have 2 cats and they have 2 different names, this is unique. If I had 2 cats with the same name, that would not be unique. And so this is really key to building good REST APIs. The next thing is that REST is built on HTTP, and HTTP methods are used to act on resources. They describe actions on them. REST does not use all the features of HTTP, so it is a subset. The methods that we will focus on are get, put, post, patch, and delete. There are other HTTP methods like head and options that you may sometimes see in REST APIs in special cases. But since those aren't really core, I won't get into them. The next thing, which is important, but not really a big topic, is that you use well-defined and consistent representations for your resources. This is not the model design. It means that all your requests and responses are JSON effectively. And this shows up where your content type is application JSON for both your requests and responses. And technically, it doesn't have to be JSON. It could be XML, but for all intents and purposes, we are generally using JSON in REST APIs. And so that's really one of the key points, is that you use something that's well-defined. You don't make up your own format, or you don't use inconsistent formats. The next thing that is probably the second most important is that APIs are decoupled from implementation. If you have a coupled implementation, it makes it really hard to maintain your software. So what does this look like when it's decoupled? Your clients, the people calling your API, don't know what your architecture is, and they don't care. They don't need to know. It doesn't show up. It doesn't impact them, whatever your architecture or coding language choices are. Another way to look at it is, if you need to rewrite your code, your API stays the same. When I say rewrite your code, I mean more of a refactoring, not a change in the business logic. So the business domain of initiating transactions, completing them, producing invoices may not change, but if you have to switch from Python to Java, or changing one web framework to another, or splitting two services, you can do that with a decoupled API. The customers don't need to change anything, and your API stays the same. So that's a decoupled. Another example of decoupling is that you don't dump your database schema into your API response. This means that your customers now depend on your database schema staying the same. And that's not great. If you have to change your database schema to add a column, now your customers either have to account for that column, or maybe you want to change a data type. So that's like a really deep coupling way down into your stack where the customers depend on your models, and that's not very good. So that's inflexible. It makes it hard to maintain. And again, if you have external customers, they just aren't going to upgrade. It can take months or years to get customers to change their behavior once they start using your product. The last thing, which is key to REST, but for the most part, it's sort of generally implemented, even without thinking about REST API design, is that REST APIs are stateless. This means that requests from the same client do not need to go to the same compute resource. Most platforms and frameworks that are used to build REST APIs build this in. You don't have sessions. It means that if somebody requests a product page with one request, that same request doesn't have to go to the same host if they want a product image. So no sessions, no state. This means that if you want to add compute resources, spin up another host, scale out another instance of a serverless function, it can immediately start taking new requests. It doesn't have to start new sessions. What does a stateful application look like? One thing to consider is online games. So MMOs or massively multiplayer online games. There is such a massive amount of state that you can't just load it up onto any server. Similarly, you want to kind of load it up once and keep everyone that needs that state in the same spot. Users that are playing games like that actually select their server, so they know which server they're on. That is coupled, and it is really stateful, but it's necessary to have real-time hot data available all the time, so available data. So you could not build a REST API for this situation because it needs state, because it requires the client to know their server. On that note, you probably wouldn't even be using HTTP for that. So again, if you're not building an application that uses HTTP, you're also not using REST. Okay, so that is the theory section. I'm going to add a summary here. So all resources are uniquely identified with a URL. HTTP methods are used to describe actions on resources. We have a well-defined and consistent representation for resources, so content, type, application, JSON. We are decoupled. We can be really stealthy with our code once our API is well-defined. And we are stateless, which means we can scale in and out flexibly. And those are part of the benefits. Decoupled APIs support scalability and flexibility, as I mentioned. We build cohesive and meaningful APIs. In my opinion, when you build a good REST API, you can almost read it in English what it's doing. And so that's something I appreciate about REST APIs. It can more easily support routing and caching. You can support routing and caching in other systems, but when I have built and maintained API gateways, it has been a lot easier with well-defined REST APIs than some of the other design patterns. All right, so from this point on, I am going to go through an example of a REST API. The domain that I'll be looking at is GitHub. So hopefully everyone is familiar with Git. If not, it is a revision control system. People use Git to collaborate with other developers on a code base. GitHub hosts the Git repos that people use to collaborate. So in GitHub, we have repositories. This might be a single application, you might have multiple applications, but it is a chunk of code that's in GitHub that GitHub is managing the Git actions on it. So commits, branches, and getting into that, the repositories do have branches. So the main branch might be the source of truth code. This is what's in production, or this is what we're all working off of. So that's a branch that can be in a repository. Our repository has multiple branches. As you are developing on a project, you'll create a feature branch that you use to develop a feature. Once you've completed your work on the feature branch and you're ready to merge it into main, then you'll open a pull request. In GitHub, this is called a pull request or a PR. In other systems, it can be a merge request, MR, or code review, CR. This is when you want to request that your teammates review the changes you've done in your feature branch that you would like to put in the main branch. When your coworkers are reviewing this, they will be leaving multiple comments. As you are working with the team on a repository, you will also have multiple PRs. And GitHub has multiple repositories, each with their own branches and PRs. So we are going to look at how the GitHub REST API has built this, and I'll break down why it is that it built things in this way. And let me share the link to the GitHub REST API. So first off, let's talk about branches. So you might have a repo. I picked one of the recent repos I looked at called Spring Boot. That is a Java application framework, very popular to build REST APIs. And they'll have multiple branches. So they have their main branch and they have 2.3.x, which might be a feature or a release branch. So how do we build our unique identifiers for these branches? So I'd like to uniquely identify main with a URL. First off, we always apply the base URL, api.github.com, to our unique identifiers. The advantage here is that once you get the URL with the unique identifier, you can just immediately make a call against it. You don't have to do string concatenation. You don't need to remember, is it api.github.com or is it github.api.com? When you identify the resource, it is the URL that you need to use, so there's no confusion there. So let's take, a naive stab at, well, how would I identify the main branch? What if I just say, okay, api.github.com, we've got branches, this is the main branch. There's a problem here. The main branch name is common across a lot of different projects, so this is not a unique identifier. So we need to add uniqueness somehow so that we don't have any ambiguity. One option is to add artificial uniqueness, where you get some randomness and you throw it into the identifier, and that makes it different from all the other identifiers. This can be a UUID, GUID, a globally unique identifier. And I see this pattern a lot. And so that's fine, but it's kind of unnatural for me to say, I'd like to get branch 04B6FF16 when the branch already has a name main. The other option is to build your API around the domain and use the domain structure to build that uniqueness in. So we know that the repository Spring Boot is unique, and within that repository, the branch name is unique. So can we use that structure to create a unique URL? I'm cutting off some of the components. This isn't a full URL because there's only so much space on a slide, but you would have that HTTPS github.com in front. But with this URL, we have the uniqueness from the top level entity, and then we add in what's unique within that top level entity into repos Spring Boot branches main. And that's what you end up with for the branches API. When you fully expand it, it actually looks like api.github.com repo spring project spring boot branches main. So what's happening here is GitHub has for a repository to be unique, it's the name plus the owner. Again, there's only so much space on a slide, so I didn't include that. But the reason for that is because I can fork a repo and it would be Alicia Spring Boot instead of Spring Project Spring Boot. And that again is the uniqueness of the domain. So they created a combined identifier that identifies the unique object. And in some ways it is similar to designing database schema. And so I will add the documentation for GitHub repos and yeah, there we go. All right, so I have these URLs and I've got the types in them. So what's that about? The URLs for REST APIs generally follow that pattern, type ID, type ID. Sometimes it's type plural or sometimes it's type singular, depends on what your style is. But the reason this is done is because it's part of that uniqueness. So if I have a product page, I want to look at a product page on some online store, and they have comments and images, sorry, reviews and images. So if I do product page 1, so product page, my product 1, is that the image or is that the review? So in order to make sure it's unique, you add the type before the ID. And just to note, the URL without the ID refers to the collection. So for example, repo Spring Boot branches refers to the collection of branches, not a specific branch. Adding the ID refers to that specific branch. And when you think about plural versus singular, if you're talking about a single branch, repo Spring Boot branch main kind of makes more sense. But when you talk about the collection, having it plural makes more sense. Just pick consistent ones. I've seen both in use. Okay, so we added uniqueness artificially, which can happen, but it's not always great to model. It's much better to model your domain in your URL. But what are some other options we could have done, but maybe wouldn't have been as great? So we have repo Spring Boot branches active main. Maybe we have active branches and we have archive branches, protected branches. There are different types of branches in GitHub. We could add the status of the branch to make it more unique or to add more of our domain model. The problem here is that the status of the branch could change. So that means that the client would have to continually check, is it an active or is it an archive branch? I had this URL, but it changed, so now I can't use that URL anymore. And so that's not a great URL because we'd want to have it unique and unchanging as much as possible. Another thing we could consider is maybe I'm using AWS, Amazon Web Services, to host my website. And I have multiple regions, multiple physical locations where I have my data. So I have US East 1, which is a data center on the East Coast of the US, and maybe I have US West 2, which is a data center on the West Coast. And I want to distribute my repos in different locations. So I have this URL that says this is the location of my server. That's not great because if I want to move my data, then the customer has to change the URL. So that's kind of bleeding your implementation into the API. The last one is if you put the service name in the URL. So repo service, repo Spring Boot branches name, or maybe branch service, whichever one it is. This also creates coupling. It exposes your implementation to the customer. If you want to change your service name or you want to split your service in two or merge it or change the technology, either you have to keep an old URL that no longer makes sense, or you're going to have to get your customers to change, which is not going to happen. That being said, you could use repo service for your internal URLs. This is what a lot of companies do for internal routing, but you wouldn't want to use this for your external API that you're giving to your customers, whether they're external or internal customers. Okay. So we have this URL and we can use it to make requests, but when we get a response from a request, we also want the URLs in the responses so that we can traverse the tree of resources. So when we get this response, and this is pulled from the GitHub examples, these responses are absolutely massive. So I'm trying to focus on one specific point here is that when you get the branch information, you're also getting information related to all of its related resources. So there is a URL that goes to the specific commit that is on this branch. Note that it has the full URL. So as a user and as a client, I can get my response.url and just immediately make a request. It's a full URL. I don't have to do string concatenation. I don't need to do any formatting or templating. It gave me the resource. I can directly interact with it. And that's another part of REST, is that the resources, it makes it easy to traverse the tree of resources by always having the URL available. That being said, I do see a lot of APIs where you'll be given an ID and you need to construct your URL. It puts a bit of work on the client, and sometimes if it's an internal client, that's okay. But it does make it more convenient for external clients, for external customers, if you just give them the URL they need to use so they don't make mistakes with string concatenation. All right, so we went over how to make a URL for a branch. Now let's look at some other entities, other resources that we could make URLs for. So what would be a good URL for a pull request? GitHub calls these pulls but that's the type name in the URL. So I will give a couple of options and you can think on it, and then I will explain which one is the best and why the other ones weren't so great. So we can have API to github.com pulls 55. Because pull requests don't really have a name, you're not really naming your pull request, the description could change. So you wouldn't want to use the description as an identifier. GitHub assigns them numbers starting from 1, incrementing integers as more pull requests are opened. So that's where the 55 comes from. We could have API.github.com pull service repo Spring Boot 55, repo Spring Boot pulls 55, or repo Spring Boot branches main pulls 55. So from the example I gave before and from the ideas I've presented in other parts, like what makes a good URL, what makes good decoupling, a decoupled API, we'll go with C, which is repo Spring Boot pulls 55. This looks really similar to branches, the only difference being that there's this incrementing integer because there's really no name to it. Now with A, we have the same problem where we just use main as the name, not specific enough, so that's not going to work. Putting the name of your service, like the pull service, repo Spring Boot 55, and not putting the type in the URL at the end, you're coupling and you risk not having enough uniqueness. Spring Boot also has other repos also have other entities on it, like issues that also have incrementing integers. So this one's both ambiguous and coupled with the backend. The last answer is not great because it's off a branch, which isn't wrong. You do make a pull request off of a branch, but it's ambiguous because there's usually 2 branches involved. So you have the source branch and the destination branch, and the destination branch could change, but it's still a little ambiguous what's going on here. And it's not really how people interact with pull requests. We think about pull requests as being in a repository, not off of a branch. And it makes it a little harder to find them if they're off of a branch name. All right, so next round is how about comments on a PR? And this one's a little more interesting because there's a bit more nesting here, potentially in the URL. So again, there's some options. Think about it for a sec, and then I'll go through which one is the best one. So we have Spring Boot pull request pulls 5511. Again, length is an issue when I do the full URLs for the slides. We have reviewers, Bendz comments 101, pulls 55 comments 101, and Spring Boot pulls 55 comments resolve 101. So again, you should have some ideas of what you shouldn't do and kind of what looks good when you think about the domain. All right, so the one that is the best answer is pulls 55 comments 101. Really similar to how they did pull requests, comments also have integers assigned to them. Comments don't have a natural identifier, but also, you know, the numbers are a little more readable than a UUID. So for the first one, it has that drawback where the type isn't specified. So if a pull request has any other resources under it, it's not clear, is 101 referring to a comment or is it referring to something else? With B, you are using an attribute for the pull request. So a pull request has a reviewer. There might be multiple reviewers. It's not necessarily, it's going to be in flux. The reviewer of a comment will stay the same, but it's not really how the domain's modeled. So more uniquely, you'll have the comments under the pull request. So that's what C goes with. And then D, again, you don't want to put attributes that might change in the URL. So having resolved 101, you could unresolve it, and then the URL will change, and then a client will be upset because, hey, why do I keep getting bad responses when I use the URLs you gave me? So that's for unique identifiers. And let me just add some links to documentation in the chat related to comments and pull requests. Okay, I will move on into HTTP methods. So in my opinion, building the right URL is the hardest thing. And it does have a lot to do with how did you model your domain. Domain modeling is a whole other presentation. So I'll focus on just REST for now and go into the HTTP methods. We have get, which is get, list, or read resources, no modifications, read only. We have post to create a resource. We have put to also create a resource or update it, patch to also update a resource, and delete to remove or delete a resource. Get and delete are the most clear and easiest ones. Get is a read, delete is a remove. But among these middle ones, post, put, and patch, we have some creates and some updates, and which do you use when? And I will go into that. First off, though, how do we use these HTTP methods? So we might have a get method on a particular URL. This means I'm executing the get action, and the result will be the information describing pull request 55. So we use that on a specific pull request. I mentioned before that if you don't have an identifier at the end of the URL, it refers to the collection. So when we do a get on pull request for just pulls, no 55, it's going to give you a list of items in that collection. That's how people can explore the API. So you can get a list of repos, find the repo you want. For that repo, get the list of pull requests and find the pull request you want. Keeping in mind that every time you get a response from one of these queries, it's going to have the full URL of the thing you're looking for. So it makes it really easy to traverse. As a note, generally when you're building these APIs to do a get on a collection, you don't return everything. You use pagination, which whole other topic. There's a lot of different ways to do pagination, but just keep in mind, if you have a million pull requests, don't return them all in the same response. All right, so the fun part of the HTTP methods, which is post, put, and patch. So there's some overlap in what these do. Post can create, put can also update, and patch can update. So now, which one do you use when? Update is the easiest one to clarify. For a put, it is a full update or replacement. This is when you're going to completely overwrite an object. With patch, it is a partial update or an edit. Now, if you think about put, you can think about an API like the YouTube API for uploading videos. When you upload a video, you're never going to update a piece of binary. You're going to do all or nothing. You can't do a partial update on, the bits of a video. So that's always going to be a full replacement. So the YouTube API for uploading videos, for updating a video, is put. When you think about, say, GitHub comments or GitHub pull requests, you can edit it without updating the entire thing. So you might have update a comment and you use patch. That is a partial update. When it comes to GitHub pull requests and GitHub comments, it doesn't really make sense to do a full and complete update because there's some information you're not allowed to edit. So that's updates, which are much easier to explain. When it comes to create, though, put has a similar idea where you're putting the whole thing. sometimes with post, with pull request, you might be able to leave out the description and it's blank. But for put, you have to provide all the information. The other thing about a put is it's kind of a bring your own identifier, create scenario. So if users aren't allowed to define their own identifier, then you would not use put for create. A lot of times when people make APIs, they will prefer to use post for create. So if you're not sure, you can default to post. If you don't use put and post at exactly the right cases, you won't be following the best practices, but no one's going to come after you most of the time. So another aspect, just referring to the URLs that are being used here. With post, you never have an identifier. So you're always doing a post on the collection. I want a new thing that is a pull request, and you give me the identifier that you created. So you do a post without an identifier. A put, you always have the identifier, like I said. If you can bring your own identifier, like Amazon Web Services S3 Simple Storage Service, you're allowed to say, this is going to be my identifier, and please drop this binary under that identifier. So that's allowed. But in some cases, you can't provide your own identifier, so you would only have an update scenario for put there. And then for patch, you have to be able to identify the object that you're changing. That's post, put, and patch. So looking at an example there, if you want to do a post on the collection API for pull, so the collection pull request, I'm going to add a payload there. I will get the pull request 55 content. So I create a new thing and I get an identifier as output. I now want to update it. So I will use that identifier and do a partial update on it with my update payload. And then usually you get the full object back. You don't have to return the full object when you do an update, but it's much more convenient for the client when you do, so that if they update the pull request and they get the response back, they can refresh their page with the response versus having to get again what they just updated. And then finally with put, there isn't a put API for GitHub pull requests, but I'm adding it here just so that we have good examples, like have a complete set of examples. If you want to create it or fully update it again, you would use the identifier in the payload. Now with put, if you're dealing with binary data, you're not going to return the entire chunk of binary data that person just updated. Generally, you'll return the metadata on it. So, hey, I uploaded this YouTube video or I uploaded this file to S3. Here's the metadata on that file you just updated. Okay, so let's go over what we learned with another think about it yourself kind of quiz. I have the operations, the HTTP methods on the left, and there are going to be a couple of scenarios on the right. And so let's think about which HTTP method I would use for each scenario. So one, I want to delete my comments on a pull request. I want to edit my pull request description. I want to submit a pull request for review. I want to list the comments on a pull request, and I want to upload a new profile photo. These are not matched up correctly. So I'll go over which ones they match to. Some of them, hopefully they're all clear based on the descriptions I gave earlier. So the first one, delete. Delete's one of the easy ones. You want to get rid of it, you just use delete. There's really not a lot of complexity there. In terms of editing, so I want to edit something that already exists without fully replacing it. We've got patch. If I want to submit something new, a new item in a collection, we will do a post. If I want to list the comments, I'm doing a read operation. So that would be a get. And finally, if I want to upload, say, a piece of binary data that's an all or nothing update, I might use a put. Again, this API does not exist in the GitHub API, adding it for completeness so we don't have multiple domains getting mixed up here. Okay. So we have our URLs. So we've got our wonderful unique identifiers based off of our domain, and we have a set of actions we can take on them defined by HTTP methods. So how do we know what happened? We use HTTP response codes to explain, how did that go? Did it work? Did it not work? So an example here would be a get on the 55th pull request in the Spring Boot repo. If this is successful, I will get a 200 OK along with the content that I wanted. However, if I want to get information about a pull request, but this pull request doesn't exist, I'm going to get a 404 not found, saying that resource wasn't found. So these are sometimes like very common in REST APIs. There's really a subset of response codes I'm going to go over here, but 200 okay. You're going to be returning that whenever something's successful, with one exception, and 404 not found. REST APIs are all about doing things on resources. So the resource exists or it doesn't. 404 is going to come up a lot. And, things are, people might start trying to loop through pull request IDs, just increment them. So they might go through, where are the pull requests? And once I hit a 404, that means that it doesn't exist. So people will do strange things like that. The special case that I mentioned is that if you do a post and a payload, you create a new thing, you'll get a 201 created instead of a 200 okay. If you use 200 okay, there's no REST police that are going to come after you. And I see that often. But just like I see post used for update, like I've seen post used for both updates and edits. If that's how you want to design your API, there's, what makes sense to you is what makes sense to you. No REST police, there's nothing enforcing it. Similarly, 200 versus 201. Some people find it easier, just use 200s for everything. And that means that it was successfully created and you return that content. Now, what if we go to edit our pull request description, but instead of passing in a string, we pass in an integer, and that is not valid, in which case we will get a 400 bad request. So these four response codes, 200 okay, 201 created, 404 not found, and 400 bad request are what I consider the core response codes for a REST API. There are many, many other response codes that relate to specific domains. For example, you will have 401 and 403 for authentication and authorization. You can have those on your REST APIs, but it's not really part of the RESTful design. It's part of security on your API. All right. So back to the theory and what we've covered. All resources are uniquely identified and retrievable with URL. So we've got our domain modeled unique URL. We've got our repos, Spring Boot, branches, main that uniquely represents our main branch. And we can use HTTP methods to take actions on them. We can get the pull request, create a new pull request, full update we don't have, but we have update with patch and delete. And then we use response codes to communicate what happened. And when you're looking at requests and responses, it's extremely easy to read. Get on this URL, which is a branch, responded with 200. Okay, I tried to get this pull request and it exists. So it's kind of readable when you look at the request and response, what you're trying to do and what happened. And so that makes it descriptive. It certainly makes it easy for me if I'm debugging failures in my applications to know what the client intended to do. And then recapping some of the other theory points. We're using application JSON for well-defined objects and representations. We're decoupled. We're not putting our server regions or our service names in our APIs, and we're stateless. We don't require clients to make requests to the same compute resource. Now, people complain about REST, and here are some of the complaints that you will hear. I get too much information. The JSON responses can be absolutely massive. They have a ton of information. Did you really need all of it? Maybe I didn't. And now I'm on the front end with this giant JSON payload that I have to parse and search and traverse. So that's a lot. That's a bit of a problem there. Second, I have to make a lot of requests to get everything I need. So I want to get the pull requests on Spring Boot repo. Okay, I have to make that request. I'd also like to find all our pull requests for me. So as an author, so I get all of those. So I now need to make a request for each one of my pull requests. And then I'd like to get the list of comments on each pull request. Okay, so there's more requests. So I have to keep making requests and requests and requests. And maybe all I really wanted was to get a count of comments open on my pull requests. Or maybe I just wanted to get a list of authors on a particular pull request. That's a lot of effort. And then every time one of these many requests that I have to make fails, I have to have all these if-else's, catching exceptions in my code for every different level where it could fail. And so now I've got this complicated application where I need to manage partial failures, and I'm consuming a lot of memory and compute to parse these gigantic responses. So one of the alternatives to REST to solve these specific issues is GraphQL. This is an interesting technology built really with a focus on front end and mobile. If you're doing service-to-service communication or you're offering an API as a product, it's not necessarily going to solve your problems because you might not have those REST problems. So what is GraphQL? You can make a single request to get only what you want. You can say, I only want the authors on comments on these pull requests. So you make that one request to say, get me all the pull requests where I am the author and get me the name of the first comment. One request. Every single request is a post. So forget all the other HTTP methods. It's just a post. It's always on the same URL. So forget resource-based URLs, and it always returns a 200. So failed 200, good 200. So when it comes to, at least in my opinion, when I'm doing gateway routing and I'm trying to debug, I do find GraphQL frustrating because everything's a post and you always get a 200. But it also means that customers don't have to worry which URL am I using, or is this API using put or patch for edits? Everything is a post. And you don't have to manage failures because internally GraphQL will manage the failures for you. And that's all part of this. It's a well-defined schema with libraries supporting client generation. So you're building a GraphQL schema in the query language. So you have to follow these rules. You will get a library that will generate your client libraries for you. So it'll generate your data types for you. So it gets really easy to use. And the requests are automatically put into this well-formatted schema language that manages partial failures for you. So in your response, it'll say, here's the data we could get, and here's the data we couldn't. But you have a limited set. You don't have to worry about managing exceptions yourself. So GraphQL is nice. It has its drawbacks, but for people who say, we really like REST modeling, but unfortunately our clients only have so much memory, and because they have to make 5 requests to load a product page, our load latency is 1 second. And so when you hit limits like that with REST APIs, it doesn't mean your REST API is bad. It can be just one of the limitations of choosing that architecture. So that is everything I have on REST APIs and designing them. I will take questions if anyone has questions.